Small and medium enterprise are the backbone of Asian economy. Instead of heavy industry, the SME has more capital investment in infrastructure, then higher contribution and potential to grow up a nation economies. SMEs contribution an average of 44.8% to the GDP of Asian member states. In Malaysia, the SME account for approximately 39.5% of GDP in year 2024. This is a tremendous impact for Asian members' economy and society. Unlike the heavy industry, these SMEs cannot afford intelligent factory overhauls. If a single motor fails in an electronic production plant, especially in Klang Valley, this may force these factories to wait a machine breakdown before fixing it. This results massive financial losses and production delays. Furthermore, while modern machines have hundreds of sensors, their data is often wasted and ignored. To address the solution, our industrial predictive maintenance dashboard, the MacMod, which is the machine condition monitoring dashboard, act as a main character to help the SMEs recover from the disaster. MacMod is an AI-driven industrial IoT, Internet of Things, and software as service platform. Instead of reacting to failures, our system acts as an AI doctor. It monitors live sensor of data to predict machine failures weeks in advance, helping factories achieve zero unplanned downtime. Now, I will pass it to our colleague to show you the demo.
To build this system, we carefully selected a simple yet powerful tech stack, focusing on efficiency and speed. We use Python as our backend engine. It processes complex machine sensor data and applies algorithm to accurately calculate the remaining useful life, or RUL, for each machine. For the front end, we choose Streamlit. It allows us to quickly transform our Python script into a clean, interactive, and responsive web dashboard without needing complex web frameworks. This streamlined approach helps us develop a robust and scalable prototype within a short time. In addition, we integrated MySQL for database management. This ensures our data is systematically organized or more reliable and easily accessible for future analysis. Let's look at our front-end demo. You can see here is a highly interactive and enterprise-grade dashboard. At the top, user can instantly view the real KPIs and allow user to directly check the RUL for each machine in the system. In the center, here shows that the asset help module dynamically ranks machines. Once the machines nearly failure, the system will be automatically flagged with the critical or warnings badges based on their RUL. On the right side, we can saw that the facility maps over there. This function allows users to check the different machine on their devices. As we can see, the red dot shows that the machine are not functioning well, whereas the green dot is show that the machine are functioning well. For the intelligent diagnostics terminal part, this part allows you to update their machine condition. For example, they have to update temperature and vibration and so on. After they finish the updated, the system will show that the status of the machine, whether it's good or bad. For the machine maintenance part, this part can allow user to schedule their maintenance tasks. The user, they just have to pick the machine they want to maintenance and pick the priority level, which is routine, high, and critical. And with the job description, then they can confirm the schedule. After they confirm the schedule, the maintenance task will be shown on the active maintenance queue. Then the machine will be always in the maintenance status. Unless the user click the complete button, then the machine will recover back to the active status. Moving on to the machine control panel. This panel can allow user to add on a new machine. So they just have to input a new machine name with the serial number. Not only that, the user, they also can update the machine details. For example, they can make changes for their machine name and also the serial number. They also can pick the status, which is active and inactive. Now, let's talk about the business side. Our business model is based on business-to-business software as a service subscription. So we have offered two-tier plans. The first one is basic one, which include the simple dashboard monitoring, and for the second one, which is the enterprise plan. This plan include the API integration for live sensor stream and advanced AI alerts. For now, I will pass to my colleague to explain the future potential.
For our market segments, we primarily targeted SMEs, small and medium enterprises in the manufacturing, heavy machineries, and automotive parts sectors. Why do we target SMEs? Because these companies operate on tight profit margins. A single unexpected machine breakdowns can severely impact their quarterly revenue. They are extremely eager to transition to Industry 4.0, but they lack the massive capital required for traditional, heavy infrastructure upgrades. They need an affordable plug-and-play entry points. Furthermore, our direct target users are plant managers and maintenance engineers who need actionable insight daily, not just raw and confusing data. In our competitor analysis, the market is highly polarized into two extremes. On the lower end, the majority of traditional factories still relies on manual Excel sheets and whiteboards. This method is entirely reactive, highly prone to human error, and has zero AI predictive capabilities. On the higher end, giant ERP systems like SAP or IBM Maximo exist. However, they are overly complex, require months of deployment, and demand dedicated IT teams, making them way too expensive for SMEs. MacMod perfectly fills this gap. We offer a lightweight, highly intuitive SaaS solution that requires zero IT overhead. It can be deployed in days instead of months, providing enterprise-grade AI prediction at a fraction of the cost. Finally, looking at the room for future improvements and potential expansion, we have a clear three-phase roadmap. First, hardware and edge integration. Beyond just uploading files, we can plan to connect MacMod directly to physical IoT devices like Raspberry Pi and industrial sensors using standard protocols like MQTT. This will enable true automated live data streaming directly from the factory floor. Second, algorithm upgrade. We will upgrade our predictive engine to advanced deep learning models, specifically LSTMs, long short-term memory networks. LSTMs are exceptionally powerful for finding complex degradation patterns in time series data, pushing our accuracy even higher. Third, a mobile ecosystem. We aim to build a dedicated mobile app. Engineers will not only receive real-time push notifications for critical alerts, but they can also scan QR codes attached to physical machines to instantly view its health dashboard on their phones. MacMod isn't just a dashboard. It is the most accessible bridge to smart manufacturing. That's all from us. Thanks for watching.